Hey guys, this is Satyajit and welcome back to my channel and welcome back to another generative AI project series. Well, on my channel, there are multiple generative AI projects, there are multiple machine learning and deep learning projects that you can go through and use it as your own portfolio project. And in this video, we are coming up with another new and beautiful idea on creating a generative AI project. Now, let me try to explain you the use case. Now, this is one of the use cases that I did in my current company for a particular client, where the problem statement was very simple. The client wanted some of their team members to interact with the database, but those team members were not proficient in SQL and they still wanted to interact with the database and get results. Well, this is a project that will definitely help this particular use case. And let me tell you that this use case is not specific to any domain. If you come from any domain, healthcare, retail, sales, marketing, you can pretty much implement this project for any kind of domain. This is a text to SQL chatbot where we will be leveraging generative AI in order to create a chatbot where you can easily ask a question in natural language. The chatbot will be able to create a SQL query out of it. It will be able to fetch results from the database directly, and you will be receiving the answers in natural language. This is going to be an end-to-end project. If you like this video, please like, share and subscribe the channel, and also let me know in the comment section on what topic or what project video I should come up in my next video. Apart from that, the project codes and files will be provided to you at 100 likes and 50 comments. See you in the video, and I hope you enjoy this video. Hi, welcome to this new project on text to SQL large language model chatbot. Well, this particular project is not binded with any particular domain. That means this project is not specific to healthcare, not specific to banking, not specific to telecom. In fact, it can be applicable in any kind of domain that you are working with. Let me try to explain you the problem statement. So usually when you are working with different type of companies, right? Let's say you are working for an MNC or a startup, doesn't really matter. Everybody has a database, right? Whether some companies have SQL database, some companies have MongoDB database, some companies have Apache Druid, Cassandra, and there are tons of other type of databases, right? But eventually everybody's work is to store data, right? uh, right now, let's say technical team is there. So I will write down there is a team here, and this team is your tech team. I will write it down as tech team. Now, if tech team needs to access the database, there are different scenarios in depending on different companies. Some companies have allowed their developers to access databases freely. Some companies have rules and regulations where the tech team needs to go through a database management team. They can request access, and they can get that access, right? So imagine you already have access to your database, and for instance, I'm talking about a very simple database, let's say a SQL database. Now, usually how do we interact with SQL database? We either connect through a tool like Microsoft SQL Server, or maybe MySQL Workbench, or it could be Oracle database, or it could be, some online Snowflake database. Eventually it's a SQL database, right? So what really happens is, we as developers, we directly work with the tools and get the queries from it, right? And we know how to form our queries. Now try to understand this use case. Imagine you are a non-technical team, right? Now, non-technical team does not have an access to database. Moreover, they don't understand SQL language. So from this database, imagine there are thousands of tables, right? Now, if this tech team wants to get access and find the total revenue for this year, which potentially could be, let's say, a simple select query, select sum of revenue from X, or maybe from X, Y, where X dot ID equal to Y dot ID and X dot year equals to 2025. Just imagine it's a random query that we have mentioned. Imagine using this query, sum of X dot revenue, something like this, right? Now this will eventually give you the output as, let's say, the total revenue for year 2025, let's say $1.5 million. Now the tech team wants to see this number, but the tech team is not experienced with writing these kind of statements. Now this is where this project comes into picture, where we can create a chatbot for a non-technical team. So basically it means you have a SQL database. What you need to do is you need to bind the SQL data with a large language model, and this large language model should be given a front end. So when the user comes in, there can be some sort of authentication layers that depends on how, to what extent you want to take this project, right? So when I will be explaining, I'm not going to talk about any authentication layer, but in real time, whenever we are building some tools, we usually integrate that with 365 services or some sort of authentication service, and that's where your software engineering team needs to come in. So let's not talk about that, but imagine the user is accessing a front end, and then the user is asking a question. Let's say in simple terms, the question is, what is the total revenue generated for 2025, right? That's basically what the user is asking. Now this is what the user is asking, and what happens is the front end is calling the large language model. The large language model is accessing the SQL database, and it is getting relevant information. It is trying to form the query. From here it is going to access, basically it is going to again access the SQL database to run this query, whether this is working or not, and it finally gives you an output, which is, the output is $1.5 million. This is a very vague architecture. I'm definitely going to talk about a detailed architecture, but this is how it is, and this is what this project is all about. So if I talk about the steps, there are different steps that we will be following here. Okay, so let me try to maybe I'll try to rub this off, because I will be drawing a new architecture shortly. So let's try to talk about the different steps that we will be taking. Now the very first step is going to be, we will be having multiple Excel sheets. Okay, you can consider these Excel sheets are related to sales data. So it could have sales, order, revenue, budgeting data, etc. Okay, now once you have these Excel sheets, we can load the Excel sheets and create a database in MySQL Workbench. So this is what we will be following in this project. Okay, now there are lots of things that you can modify, or you can take this project to the next level. We will talk about that part as well. Okay, but this is what I am going to do in this project. Then I'm going to analyze the tables and prepare questions from the tables. So basically I will be creating some 5 or 10 questions based on my domain knowledge. Okay. Now, why? Because eventually, once your large language model is ready, we need to test these questions there. So, we will be having some sort of like a questionnaire where we have a question. We will be generating the question with our domain knowledge. We already have an answer which can be called as a ground truth, and then the large language model is going to give you an answer, and then this answer and this answer will be checked based on something. There will be some evaluation metrics, and based on that we will be able to identify whether this large language model has done well or not. Okay, so let's move on to the steps. The next step is going to be code setup for connecting the database and loading. Next will be building a pipeline to test the model on the questions. Okay, now eventually the number sixth step is experimenting with different models, but I will experimenting with one large language model and also adjusting the parameters of the model. Okay, so in this project I'm going to experiment with one large language model, but I will also tell you how to experiment with multiple, so that you will eventually be able to test it out with multiple large language models. And then of course analyzing the response of the model using various matrices, and of course fine tuning the results for better response. Okay, so vaguely this is what the number of steps that we are going to follow. Okay, now there are multiple areas where you can take the project to the next level. That could be here, where you can experiment with 10 different large language models, and then you can also analyze the response with multiple matrices. We will be talking about evaluation matrices, and then of course this one. So point number 6 till 8 is something that you can take the project to the next level. So as I have told multiple times, when you are working on a machine learning project or a generative AI project, right, building the first version of it could be very simple, straightforward, takes less time, but building the ultimate model that will be best in all kinds of scenarios takes time. So I will be showing you the direction, and I'm assuming that you all will be able to follow that direction and take this project to the next level. Hi, let's jump into the next part, which is architecture diagram. So in the previous video I showed you a vague architecture diagram on how the flow of this project will be, but of course in this video we shall be deep diving into this. We'll be drawing an end-to-end architecture diagram, and then I will explain you how to set up the data pipeline and schema preparation, and eventually we will jump into the project. At the end of the project we will also try to evaluate the model with multiple evaluation metrics. So treat this as an end-to-end project, but as I have told you in the previous video, this can be considered as an end-to-end project for sure, but there are n number of ways that you can use to take this project to another level, right? If you want to do that, feel free to reach out to me on different techniques, different ways on how you can take this project to the next level. And let me also tell you that this is one of the live projects that I have done in the past for a company. But in this project, the data that we are using is dummy data. But the use case is pretty much industry level live use case. Okay, so when I talk about architecture diagram, the very first thing that comes is the Excel sheet. Okay, let me draw this. This is your Excel sheet. Okay, so we will be using multiple Excel sheets that will have different type of information. Okay, I can pretty much show that as well. I will show the data in the next video. So we have multiple Excel sheets. Okay, the very first thing that we will be doing is we will be pre-processing it. Okay, whenever I start working on this project, I will also explain you with respect to this diagram on which step are we in and which step are we going to take, right? So that you will be able to relate the architecture diagram with what we are doing. So after pre-processing, we basically load the data into a database. Very beautiful database diagram I have drawn. This can be considered okay. So we have let's say a MySQL database. We will be loading the data into that, right? Now after we load the data into MySQL database, right, what we will do is, imagine your MySQL database. So imagine this is your database, right? You have a table, you have a table, you have a table, you have a table. Let's say I'm taking example of uh, 4 tables, right? Table 1, table 2, table 3, table 4. Now imagine table 1 and table 2 are connected using customer ID, right? Table 2 and table 4 are connected using order ID. And let's say table 4 and table 5 are 3 are connected using some other ID. Also table 1 and table 3 are connected using some other ID. Now this is what we call a, what do we call this? When we are trying to build relationships between different types of tables in a SQL database or in a generic database, we call it as an entity relationship diagram, right? I will also give another table. Let's say there is another table which is not connected to any of them. There is another table. Now these two tables are connected, 5 and 6, right? So 1, 2, 3, 4 has no connectivity with 5 and 6. Could be a possibility, right? So this is called as entity relationship diagram. And whenever the data is getting pushed to a database, which eventually is not our task, in reality it's some other team's task, the database team's task, who basically creates the schema and all those things. Of course, development team gives a schema to the database team, but the database team is the one who creates the table, who creates the primary key, foreign key constraints and various other things, right? So this is what we call entity relationship diagram. Now think from that point of view. If we want to call some large language model, right? Imagine there is a large language model here and I want to call a database, and eventually as a user I'm going to ask a question, right? What is the revenue of this particular table, of this particular product? Eventually you are asking a simple question, the large language model is converting it into a SQL query, right? And that SQL query can have multiple tables in it. Let's say this SQL query involves table 2 and table 3, right? So how will large language model understand this context and create this query? Have you thought about that part? This can only happen when the large language model understands the relationship between different tables, right? So here I'm talking about this part. This is for a human being to understand what is the relationship so that they can understand the connectivity between different tables. Now this information also needs to be passed to the large language model, right? If not, how the large language model will understand the relationships? Understood? So in order for your MySQL database to interact with large language model, the very first thing that you need to do is you need to train large language model about the connectivity of your database, right? So let me just delete this part, delete this part, delete this part, right? So your large language model needs to understand the relationship. Now there are two different techniques of explaining the relationship to the large language model. Either you pass one record from each table to LLM, and LLM understands the relationship by themselves. That is one option. The second option is using prompting. Explain the ER diagram relationship to the large language model. So there are two techniques. The first technique is, if you have 5 tables, right? From each table, pass one record to the large language model. I mean, as a human being as well, right? Let's say we'll try to open the data set that we are talking about. We have it here, GenAI projects, text to SQL data, right? So I'll talk about the relationship from a human point of view, right? Large language models are nothing but neural networks that works like human beings. If you give context, they will be able to understand, right? In simple terms, let's say I'm showing you this data, right? Customer table has a column called as customer index, right? And let's say there is another table, let's say sales order, right? Can you see there is a column called as a customer name index? Now if you, as a human being, if you see these two tables, eventually you will be able to understand that yes, this is what the relationship is, right? This column is related to this column, right? And also as a human being, you will understand that this particular column, customer index in customers table, is the primary key, and this customer name index in this table is the foreign key. And what will be the primary key here in this table? As this is an orders table, there has to be some order ID, right? And you can see there is something called as order number. So eventually if you create a ER diagram by yourself, you have this customer table, you have this orders table, you will be able to create a connection using customer index, right? So the first technique is very simple. You just pass one record to the large language model with, of course, with the column headers. The large language model will be able to understand the relationship because they are intelligent enough. And the second one is using prompting. You have to explicitly mention that you need to go through a MySQL database which has 5 tables, namely orders, customers, etc., where the relationships are mentioned below. Customer table is linked with orders based on a column. So this is what is the meaning of the second point, prompting technique. Now we will be not using prompting because that's a very simple step. Instead, I will be using the first technique here. Okay, so going back to the architecture diagram, when we have the MySQL database, let me try to rub this off because I will be changing the and let me take this little bit towards this side. Okay, now going back to the architecture diagram, after MySQL database is ready, right, I will be creating, there is something called as a SQL chain. Okay, and that is basically the first point. Okay, I'll be creating a SQL chain. Then I will be calling a schema generator. When we jump into the code, it's going to be super easy to understand. Now this can be called as a retriever. Okay, okay, that's basically your schema generator. Now here I will try to make it very simple. Let's say we have this user. Okay, I will try to draw it in a different color for visibility. We have a user. Okay, user is asking a question, and that question could be, let's say, what is the revenue of this particular product in the year 2025. Okay, let's say we'll try to write up a question. What is the total number of orders done by Mr. X? Okay, very simple question. Okay, so next is, the question is being asked, right? I will try to draw a pipeline here for simplicity. Okay, so there is a prompt template that we have mentioned. Okay, now this prompt template is not this one. Okay, even if you are not using the second technique, still you will need a prompt template, right? Because you are asking the large language model to, learn by themselves or whatever it is, right? We'll talk about that. So there is a prompt template which eventually is calling the schema, right? And here there is something called as a large language model binding. Now this architecture diagram is a bit technical. I will also try to explain you in a layman's term. And then there is something called as a output parser. Okay, and finally you have your SQL query. Now this SQL query, basically what you are doing is, this is your SQL query. Okay, this is not a SQL database. You are basically calling the MySQL database and eventually getting the output, right? And then you are passing the output to the user, and that basically sums up my entire architecture flow. So in simple terms, if you want to understand in a very layman's term, right, what's happening is, you have your data, you are loading your data into MySQL tables using SQL chain. Imagine this as your you're passing one record to create a chain, and then you have a generator, schema generator, that basically generates the schema and the relationship. As a user, you have, and this is your large language model chain, right? This is your LLM chain. As a user, you are asking a question to the large language model, and this entirely is your large language model, right? What is happening from the query? You are using the prompt template, using the schema, LLM binding, and output parser to generate the SQL query, right? So if you have gone through the very generic, very generic RAG flow architecture, you can also redraw this architecture this way. So first of all, we have the Excel sheet. Then you are loading it to a MySQL database, right? And then from MySQL database, you are basically passing your first records to the large language model for training purpose. Now large language model has the context, right? Now you also have a front end, right, where the user is asking a question. Okay, Of course, internally the question is converted into vector data, and this is also in vector data, right? All of those things are very basic things. So from there, it is eventually able to identify the context, and LLM is able to generate a question, or you can write it down as a query, right? LLM is generating the SQL query, right? And then eventually LLM is calling the MySQL database, generating the output of it, and sending it back to the user. As simple as that. Okay, so that pretty much sums up the architecture flow. um, Theoretically, if I talk about the data pipeline creation, we have data source. So the process begins with data stored in Excel sheets. I have already explained. There is a pre-processing layer. The raw data is clean, formatted, and structured. Then we have the database storage. Which basically, let me draw. So we have the first layer, which is data source, then pre-processing, then we have the database storage where the process data is loaded into MySQL. Then we have the schema extraction. I will write it down as this entire chain. We have the schema extraction where the SQL chain connects to the database. It uses a retriever to fetch the database schema like table and column names, and schema generator to organize the information, right? This generated schema is crucial for the large language model to understand the database structure, right? And then you have this text to SQL generation LLM chain part. This is your LLM chain. So you have user input, which is the prompt, and then the user's query queue is basically processed and goes through a prompt template, refines the query, and it gets combined with the schema information from the previous stage, right? And once that is done, this creates a detailed prompt for the large language model, right? So till this is basically what is formed as an input to the large language model. It gets binded up with the large language model, and then the LLM processing happens. The combined prompt, this and the schema are fed into the large language model, and eventually the LLM's task is to understand the user's intent, combine it with the structure, and then it provides you the output parsing. The raw output from the LLM goes through a output parser, right? And this is your output from LLM, and outside your LLM box you are calling the MySQL database, and your final output you are generating and you are sending it to the user. Now imagine for this particular question the output is, let's say the query generated by the LLM is, I'll try to make it little bit big, total number of orders, right? So select sum of or count of orders from order table, right? Order O, customer C, where O dot customer ID is equal to C dot customer ID, and C dot customer name is equals to X. It's Mr. X, right? Imagine this is the query generated by your large language model, right? What will be the output? The output is just a simple number, right? Let's say 15. The output is 15. Now here also, when you are getting the output, this is outside the LLM box, right? The output is eventually 15. So in this flow, the final output the user will get is 15. If you want a natural language output, instead of 15, it should answer the total. Let me write it down using text. If you want the total number of orders by Mr. X is 15. If you want this, then you also need to embed a LLM layer here. So LLM will get this answer. LLM will be able to do the chat completion, and then it will send it back to the user, right? So this is the entire architecture flow of this project. We will jump into the coding part in the next video and into more details in the follow-up videos. Let's try to jump into the data part. Let's try to understand the relationship of different sheets that are available. So to get started with, I will try to open the customer's Excel sheet. Now here, if you can look at customer's sheet, this basically has two different columns, one of them being customer index and one of them being customer names. And in parallel, let's try to open mirror board and try to create a ER diagram. So the very first thing is going to be customers table. Okay, and inside customers table there are multiple columns. I'm not going to write all the columns, but customer index looks like a primary key, right? So I'll try to write down customer index. Simple. Now moving on to the next data sheet. So this is very clear. We have different customers and each and every customer is attached with a customer ID. Moving on to the next part, which is product. Okay, before product, let me try to go into sales order. Okay, now if you look at sales order, that means which customer has ordered what and through which channel, right? So whenever it comes to orders table, the primary key is always the order ID, not the customer ID, because one customer can order multiple times, right? So there will be multiple records for one particular customer. So order number here is the primary key. Customer ID is the relationship key or foreign key, right? Because this is where the relationship will be built with the customers table. So jumping on to Miro, let me try to draw another table. Let's say orders or sales orders. Okay, now the primary key is, I will write down the primary key is order, what was that, order underscore number, order number, and the foreign key was customer name index. Okay, the foreign key was customer name index. Now foreign key is with context to customer, right? Because that's how the relationship will be built based on this. Okay, now if we deep dive more into sales order table, we have order number, we have the order date, customer name, which channel, currency code, warehouse code, from which warehouse the delivery has been dispatched, delivery region index. Now this also looks like an ID number, and there could be another file where we might have information about this particular indexes, right? Delivery region index, it could be one particular location. Similarly, product description index, because in this table we don't have the description of the product, so there could be another file with a product description index. And then we have order quantity, unit price, line total, etc. Okay, let's try to look at the relationship between this with something else. Product description index. Now you can see there is a file called as products. So if we go back and try to write it down, this could be products. Okay, now another foreign key is, I would write it down as product description index. Okay, product description index. And here the primary key is index. Got it? Now this is also linked with this based on this, right? I will write it down based on this, based on this. That's how the relationship between customers, orders, and products are built. The next part is we are still left out with this, this, and this, right? So if we go back to sales order, delivery region index, it could be, yeah, this one is region stable, right? ID. What is state regions? State regions is the state code and the state and the region. Okay, state code. State code. So this one could be this one, state code. Okay, so I'll try to draw two more tables. Table 1, which is regions, and table 2, which is state regions, and they are connected using state code, and region is connected. Where is regions? Regions is connected with the sales order based on the region ID, right? So based on the region ID. Okay. Now lastly, there is 2017 budgets, which is linked with product name, right? And where is product name? Product name is this one, right? So 2017 budgets is linked with product, and that is based on product name, right? So these are the attributes based on which the relationship is built, and this can be considered as your ER diagram. See, this can be automated. There are several online tools where you just pass in the data and your relationship will be built, right? So we also have Power BI, which is a business intelligence tool. If you upload the data there, the relationship will also be automatically built. Now if you want to have a look at it, I will quickly give you a glance of it, right? However, Power BI is something which comes under the data analytics tech stack, but for those who might know, that data analytics is a prerequisite to data science and AI, right? So it's always good if you have knowledge on Power BI, but if not, it's completely okay, right? So let's say I want to read some Excel CSV files, and let's say I want to give this folder. I'm not 100% sure whether this will work, but I'm assuming it should work. So let's say customer is fetched, load, and then we will load SQL. Sorry, the next one. Customers and then sales order. So I've done only two. Let's try to go to the relationship and see whether the relationship is built, and you can see the relationship is built, right? You can see, right, how when I'm hovering, you see the relationship is built between customer index and customer name index. Let's try to get one more file just to show you how it works. So one more file could be, so I have taken this one and this one. Let's try to take the products. Okay, products, and product should be linked with orders based on product description index and index. Okay, uh, unfortunately this is not built, which is fine, because Power BI is not able to identify the relationship, which is completely fine. Not everything is automated in Power BI, but let's try to jump into the next part, which is regions. Let's see whether it's able to find regions. I doubt this one will also be fetched. Yeah, you can see this is not fetched, but you can always create relationships on Power BI, right? So let's say sales order with products. There is a linkage between this and this. right? You can build this relationship from this table, many to one relationship. The direction is single, and see, the relationship is built. Similarly, if you want to do with region, index, and ID, that can also be done. That's it. Similarly, last but not the least, I will take state regions. This one should logically be built, I am assuming. No. And that's because of the redundant three columns. Let me try to delete it from the model and try to fix it here. Delete and save. Okay. Going to Power BI, upload state regions. See, this is purely for demonstration purpose. I just wanted to show the ER diagram. See, unfortunately, why it's not coming? State regions has these three columns. Okay, got it. Let me delete rest all the files. State regions. Delete. Refresh. And then again take this file, state regions. Let me just view it. Everything is fine. There is no column 1, column 2, column 3. And why it's still reading this one? The data in the preview has been truncated. Let's go to transform data and try to delete the first row. Yeah, now it's okay, and you can see automatically it's built, right? And it's built based on state code and state code, right? See, in Power BI, I think based on the column names and of course some internal logic, the relationship is built. Here it was not built because it's index. If it would have been product ID or something, where naming convention also plays a vital role, right? So if it would have been product ID, the relationship would have been automatically built. But anyhow, this is what we call a ER diagram or entity relationship diagram, which we have also built here, right? Power BI thing was just for demonstration purpose. In the next video, we shall be taking this all of these files and loading it into MySQL database, and henceforth we will start with the Python code implementation of this project. Hi, let's jump into the next part where we will be taking all of these files, all of this data that we discussed in the previous video to the next level, where we will be uploading these files to MySQL Workbench. This is just for demonstration purpose. We are using MySQL Workbench because we want to upload the files, the data to a SQL database, and from Python we need to connect to the database to accomplish this particular project. In reality, let me also talk about that, because this is one of the real-time projects that I have done for one of the clients. I'll not name the client, but I'll try to tell you the complexity of it and what we did. And this is basically a mock-up project for that, right? So there was a retail client, and I'm not going to talk more about that, but you can consider them as one of the best brands, French-based brands. Um, for them, actually, we were working on multiple projects. We worked on multiple greenfield projects for onboarding Microsoft Fabric and various other things, and as they were happy with our engagement, we moved on and started creating a generative AI POC, and they liked it. So we have implemented it for a small team. It was not the entire company's database. That company was managing databases separately. There was one particular team, I would say. So I will just draw it this way, that there was a team, and imagine there are databases. So this team was using, let's say, 18 to 20 different tables, right? And they had the list of that. No problem in that, right? So they wanted to create like a front end application where all of this information will be available here. On top of that, they will also be having a couple of their sustainability documents. So it was database with PDF documents. So let's not get into this particular use case because it's too complex, and it was very difficult for me to create a mockup. So I just started creating a mockup only for the first part. So let me ignore the PDF part as of now. Okay, imagine you have 10, 18 to 20 different tables. The data is available, and of course your database is a live database, right? That means every second, every minute, the data changes, right? There are multiple inserts, multiple updates, multiple deletes. So we created a front end application where of course it was created using, you can consider it as a Flask application, but in reality it was not. So as an end user, if somebody is coming and asking a question, of course in simple natural language question, then from UI, that request goes into this particular list of tables. And I mean, before that as well, from the UI, the call basically goes to the LLM chain. LLM chain already has the context of the database, and LLM chain generates the query. So LLM chain generates the SQL query, and then SQL query is executed, and then we get the output. And here again we call LLM, and then the chat completion happens, and I will write it down as fine-tuned output is given to the users. Okay, this was the use case. And for LLM, we basically used AWS Bedrock APIs. Now if somebody asks what is Bedrock, it is as simple as an AWS offering, and in that you can actually opt for multiple models that are available. So imagine it as an API, as simple as that, right? So if you go to AWS Bedrock, there are multiple things available. In Bedrock, there are multiple models like Cloud Sonnet, Nova Pro, multiple models are there. If you enable some of them, you can start using them, right? It is as simple as an API. The way you are using OpenAI APIs or Grok APIs or Gemini APIs, it's pretty much same, right? And we deployed this application in a sandbox environment created by that particular client, and you can consider sandbox as a EC2 instance. So that was pretty much the use case. So we have replicated that use case for all of you so that you get a feeling of a live project. Okay, so in our case everything remains the same. Instead of AWS Bedrock, I will be using Gemini, right? And apart from that, most of the things remains the same. In our project there will be no UI. It's just a Python notebook through which I am going to execute everything. If you want to convert this project into Flask application, feel free to do that. I have done that in multiple projects, converting my standalone file to a Flask application. It really takes like a 1 hour or 2 hours to do that. So I have not done that in this project. You can do that if you want to. and that's it. And of course, one more question to talk about is, some of you might be thinking, sir, why Gemini, or why, if in AWS Bedrock, which model we were using? We were using Nova Pro. You might be thinking, why Nova Pro? Why not something else, right? So here also, as part of this implementation, I have tried multiple models like Nova Pro, Nova Lite. I also tried Mixtral. I also tried Cloud. I would say Cloud, the 3.51, not the 3.7. Nova Pro gave us better results. When I say better results, that means we tried it on 20 different queries, and Nova Pro was almost correct on all the queries. Cloud Sonnet was also good, but only in one or two cases it failed, so we did not go for that. In this project, we have not done a lot of R&D on the type of LLM. I have just used one particular LLM. Using that, I have evaluated the metrics. So if you want to take it to the next level, you can always do a R&D on multiple large language models, right? So that's it. Moving on to the uploading part of the data to MySQL Workbench. So let's say this is your MySQL Workbench, and of course, I'm not going to teach you how to create an instance, how to create a workspace, etc. etc. I'm assuming that all of you know about MySQL. So let's say I'm going to create a database, right? So let me try to create a database. Create database, let's say text to SQL, okay? And then the very first thing that I'm going to do is use text to SQL. That means I'm going to use this database. Okay, now we are using this database. If you want to select tables, you can select, but you will not be able to see any tables because nothing is present, right? So I'll refresh this. I should be able to see a schema called as text to SQL, yes, and of course everything is empty, right? So first, let's try to do a table data input for our first file. The first file, what I'm going to do is, it's going to be customers table. Next, customers. This particular process will take some time, so please have patience in this lecture. In case you want to fast forward, you can always fast forward it. So moving on to the next one. So customers are done. Let's try to do products. Let's try to do state regions. So customers, state regions, both are done. Customers are done, state regions are done. Then let's go to regions. Customer, region and state region. Okay. Let's go for products and then budgets and then sales order. Products and sales order. Okay. Products. Done. And then finally, sorry, not create a table. My bad. Don't save. Data import wizard and sales order. That's it. Next. It will take some time and our data should be visible immediately. So the data has been loaded. Let's try to refresh the schema and you can see all the tables are ready. Now what we can do is, I'll do a quick sanity check with multiple tables, just simple select queries and quickly have a look at it if everything is good. Another level of sanity could also be with select count star, where you can just select and see how many records do you have. Go back to your Excel sheet, validate everything is fine. That should be the first level of sanity. The second level of sanity is, let me go back to the entity relationship diagram and try to validate whether these columns where the relationship has been created, based on that joins are working or not. For example, if I talk about customers and orders, right? So in customers and orders, it's connected using customer index and customer name index, right? Let's try to go back and do a quick check. Select star from customers. Okay, one problem that I have identified is the name of the columns is having spaces, customer space index. Now this is a problem that should have been fixed before the data went into the database, because usually what we do when we load the data into tables is convert column names to developer friendly column names. So this is a better solution rather than this. Okay, now I'll tell you the reason. Let's say I want to do a search on customer index, right? Let's say I will do customer index, right? Logically, this is how we do, right? If you select, it will not work because the query is not proper. What will be the fix? If you do this, will this work? This query will work, but it will not give you the expected output because it will treat this as a string. So if you run this, it will just print customer index for all the records. Now customer index is one of your columns. How to fix this problem? Instead of this, or instead of using double quotes, the solution here is use tilted quotes. Sorry. That's one solution. That's why we usually don't do this. Whenever we load the data, we make sure the column names are in this format, something underscore something, right? So now I will leave up to you. In case you want to fix this problem, you can delete this entire schema, fix it up, come back. But I'm not going to fix it. I will just move ahead with the sanity check. Okay, so this is my customers table. So the column name here is customer index, and this is my sales order table where my customer name is customer name index. Okay, let's try to do a simple join query. Now for joining, I'll try to frame up a question. Okay, let's say the question is, let's say I'll take this customer as an example. What is the total line? So what is the total line total? So line total is a column, right? What is the total line total for guess, whatever you can treat it, right? This is the question. So how do we get the answer? What will be the answer? So let's try to solve this problem. So for this one, as we are expecting the sales of the total line total of this company, and this company's customer index is 1, so I will do from customer C sales order S, where C dot customer index is equals to S dot customer name index. That's the first join statement. And C dot customer names is equals to guess company, right? Now if I do this, let's say I'm doing s dot star comma c dot star, right? If I do this, my join is working. But here you can see that there are multiple records, right? We need the sum of this particular column, this one, line total. How do we get that? Can I directly do sum of s dot line total? Will this work? No, right? It will not work. Why? Because in order to do this, you need a group by. So we will do a group by on which column? We need to do a group by on customer name index. Group by s dot customer name index. Now if you run this, now if you run this, well, it should work. I just need c dot s dot customer name index. Yeah. So you can see this is the number. If you want, you can validate these numbers. Go to your data, Python, Gen AI project, SQL to text, data CSV, go to the sales order, and here close it, create a filter on the first column, and customer name ID, just select one. Now on top of this, what you can do is either you do a sum of line total. Well, oh, maybe because of filter it's not working, so it's okay. So you can see if I just select here, the sum is 5516847. 5516847. Simple. Similarly, you can do a check for any other company. Let's say this company, Jackspin Group, and here I will just select 2, and my line total is 6832552. 6832552. So sanity check is done. Our data is loaded to the database. Everything is good. Let's move on with the Python implementation in the next video. Let's move on to the code part. So architecture is clear. In this particular project, I'm going to use Google Gemini. So let's get started with it. So the very first thing is importing all the libraries. If you're using Google Colab, it's completely fine. So let me start importing some of them, and if I forget anything, I can do it on the go, right? So I'm using LangChain's utilities, so SQL database, because we will be connecting to MySQL database. Oh wait, you cannot use Google Colab because your MySQL instance is on your local system. So make sure you are using Jupyter Notebook where you have access to the database, right? Because you will be connecting to the database, right? So from LangChain LLMs import, well, OpenAI is not needed for now, but let me just write it down. LangChain prompts import prompt template from LangChain chat models import. Actually, chat, OpenAI, and all those things are not needed, so I'll just skip that part. Chains import create SQL query chain from LangChain core. We also need output parsers, import str output parser from LangChain code runnables import runnable pass-through, and what else? Output parser is done. Yeah, for Gemini, right? For Gemini, we will be using LangChain Google Gen AI import chat Google Generative AI. Let's try to run this. In case any library fails, runnable pass through capital small t. So we need to install this. Well, that's completely fine. Let's try to do pip install and run this code. You can do it here, you can do it on command prompt or anaconda prompt, wherever you feel like. So let's wait till the time this library is installed. It's done. So I'm deleting this block and I will rerun this and all good, right? Jumping on to connecting MySQL, I would write MySQL database, right? So let's say my host here is going to be localhost because it's on my local machine, right? And my port is 3306. I will use a string 3306. Username in my case is root and password is also root. In your case, I'm not sure what it will be, you must be knowing it. Host, port, username, password, database schema we have used text to SQL, right? So schema is equal to text to SQL. What else? Yeah, MySQL URI. So let's say f MySQL by MySQL username password @host port database schema, and let's say db is equal to SQL database from URI MySQL URI sample rows in table info equals to 2, and then all good. Yeah, it's working fine. Sample rows in table info. Okay, that should be fine. Let's try to do a info 1 and show you db.get table info, and you can see all the tables data is visible here, right? So my table connections and everything is fine. Let's try to create the large language model prompt template. Okay, now prompt template will help us as in the large language model to understand, right? So from LangChain code prompts import chat prompt template. Let's say template is equals to based on the table schema below, write a SQL query that would answer the user's question. Remember, only provide me the SQL query. Don't include anything else, because I just want the SQL query. I don't want the natural language answer, right? Because if I give a huge prompt, there are chances of hallucinations, chances of getting bad results. So I just want the query. That's it. right? So for this model, my output is a simple query, not NLP based output, right? Anything else? And then provide me SQL query in a single line, don't add line breaks. Table schema, uh, question SQL query, that's it. Prompt is equals to chat prompt template from template and pass the template. Done. Now get the schema of the database. So let's say we will write a simple function def get schema. I'll pass db, and here schema is equals to db.get. I'm just passing this one. Get table info. Get table info and just return my schema. That's it. Simple method, right? Now this is where I'm calling my large language model, chat Google generative AI. Model is equals to Gemini 2.0 Flash. API key is something that I'm going to pass, definitely not in front of you all, else it will be exposed. So I will write it down or rerun this code later on. So my large language model is ready, and then I'm just create the SQL query chain using the LLM and the prompt template. Why it's failing? Default credentials error. Yeah, it's because my API key is not working. It's okay, I will fix it up, no issues, right? Ignore, and then moving on to the next part and the prompt template. So I'm just creating the SQL chain. If you go back to the architecture diagram, which is already little bit messed up, but this is what so this is your SQL chain, right? And this is your LLM chain, don't forget that. So I'm creating the SQL chain. Okay, so SQL chain equals to runnable pass through dot assign schema is equals to lambda lambda get schema and the prompt and do a binding so we need to stop whenever we spot /n SQL result, and then str output parser. Okay, so should be okay. Let me get my API key. So I have already added my API key and I have already run this piece of code. Just that it should not be visible to you. I have changed it to XYZ, but I have already fed my API key. So let's try to create the SQL chain. Looks to be fine. Runnable pass through assign. Let's try to run this. So my SQL chain is ready. Now test the SQL query chain with a sample question. Okay, so let's say my question is, I'm going to capture this in the response. SQL chain, invoke it with a question. Let's say the question is, what was the budget of product 12? Or maybe we will write the same question that we We were doing something right. Let's try to ask this question. I'm not sure whether this will it will answer it properly or not. What is the total line total for this particular company? Bracket close, bracket close, bracket close, and then print resp. Let's hope it answers. There is a failure. What is the failure? The location is not supported by Google Generative AI at the moment. Great. And that is because I am based out in Hong Kong. Um, where can I run this piece of code? So, okay, what we can do is everything is working fine. Trust me, we have run this piece of code. Um, Actually, I ran this in a different machine and I usually record all of my videos in a different setup. That is one of the reasons why this answer is failing. But there is no issue with the code. Everything is working fine. You can just test it out. Let me figure out if I can complete this video. I'll try to give a workaround, but the workaround is only applicable to me and not to you. So this is where we can wind up this particular project. Everything is working fine. We also have another piece of code which basically talks about the RAG as framework where we have validated the results. So probably what I can do is I'll skip this part for now. I will just name it as my Gemini chatbot. Okay. And there is another notebook that I will give which is Gemini chatbot including ragas. Okay, so let's try to go through this particular file and I will tell you what I have done beyond this particular thing, right? Because so far we have just tested it on one large language model. If you want to take this to another level, what we can do, but before that let me first complete this uh, evaluation of the large language model. In the previous video, we created a Gemini chatbot with few lines of code. The only problem we faced was the code was not working, and that was because of my problem, not because of your problem or the code problem. This piece of code will definitely work on your local machine if you are not in Hong Kong. Uh, if you are in Hong Kong, well, this is how it is. We need to either push our database to cloud database so that we can access it online and take this code to Google Colab so that from Google Colab you can connect to that database and the code will work. But I'm pretty much sure this code works. Okay, I'm jumping into the RAG as framework that we have used for evaluation. Okay, first of all, what is RAGAS? RAGAS is nothing but RAG assessment framework, right? You can see same piece of code. I will just take it to the bottom. This is where, yeah, this is where we ended up in the previous video. We invoked a particular question and this is how you get the answer. And the next thing is very simple. Using re, I'm basically cutting down these kind of things, and once I get this piece of code, I'm just going and executing this piece of code on my SQL database. So here is where I'm calling db.run query. Okay, so here I'm cleaning my query. The output of this is very simple, right? So let's say, just for the sake of showing you the code, let's say resp is this part. Oh, it should work this way. Okay, and you can see I'm just running this piece of code, and then if you look at the query, you can see the query is this one, right? And what you're doing is you're taking this query and doing db.run, as simple as that. And what is db? If you go up, db is nothing but your database connection that you have created. Simple. So this piece of code works. Only thing is it will not work on my system, as simple as that, right? Moving on with, so let me just remove all of these things so that whenever I pass you this code, it should work. Um, so this is where the RAG as things comes into picture, right? I'll do plus and markdown implementation. Okay, so I cannot run the codes. I will just quickly go through it. So this is where I'm calling the RAG as, I'm importing the RAG as libraries, and this is where I'm creating the chat grok. I'm passing the model, the API key. I have to turn off this API key so that it is not exposed. So when you run, you make sure you add your own API keys, and then I'm calling the Hugging Face embeddings. Now in this case, you can call OpenAI embeddings, but if you call OpenAI embeddings, you also need a API key for OpenAI embeddings, right? But as we are using Hugging Face embeddings, nothing is needed. You directly call this model internally. That model will be used, right? And using this, here I'm calling a LangChain wrapper, and I'm passing my LangChain embeddings into my um, embedding wrapper. That's it. And here is where I have created a definition of maliciousness. Is the response intended to harm, deceive, or exploit users? Aspect critic, name maliciousness, definition maliciousness definition. LLM, I'm passing the evaluator LLM, right? And the helpfulness rubrics is mentioned here. Response is useless, irrelevant, contents inappropriate. So this rubrics has been created, adapted Google's helpfulness prompt template. Okay, and I'm calling the rubrics score on the helpfulness, and that's it. And I'm calling the evaluator LLM, right? So here I'm calling the RAG as evaluator. These are the 5 questions that I have created, for whom I already know the answer, because whenever you are evaluating your RAG system, right, what we do is we create a list of question and answer, right? So let's say in this case, this could be one of the questions, right? This could be one of the questions, and the answer is 1356 da da da, right? So this is treated as ground truth, right? And then whatever your LLM responds, that is your LLM's output, right? That's how we do. Now in this case, in particularly this example that we are dealing with, our LLM is not supposed to provide you this answer. Our LLM is going to provide you the question, I mean the query, right? That means if I ask the question as, let's say if I ask the question as, what is the total this thing, right? So in this case, what will happen is, that's my question, right? What will be the ground truth? The ground truth will be the ground truth will be this one, right? Sorry, the ground truth is not this one. My bad, my bad, my bad. The ground truth is this particular query. That's my ground truth, right? So my LLM will also respond something like this, or could be different, right? So how can we validate whether these results are correct or not? Human level of validation is needed in this case. You can run this query, and check, right? If you want to take this to another level, you can add more and more large language models. That's where you keep checking all the responses by your large language model and then take a call which model is working best for you, right? So I'm not going to teach you how evaluation works because that is something that I have already taught you in different other videos. So this is your final project for this particular thing, which is text to SQL, and you can see the user input is mentioned here, retrieved context is mentioned here, the response is mentioned here, the reference is mentioned here, right? And if you go for the evaluation based on these two things, the context precision is 1, which is good. The helpfulness is 3.8, which is also good. If you want to know, then you can potentially go to grok or poi.com and you can ask, these are the results from RAG of Gemini for a use case. Whether it is good or not, can you tell me? And see, context precision is really high. That means it's an excellent job. Helpfulness also is based on a score till 5, right? So it's good. 3.8 out of 5 is almost 76%, which is quite positive. And this is what ChatGPT is also responding, right? So overall, the context precision is outstanding, which is a strong indicator of relevance. However, the helpfulness score suggests that while the information is relevant, it might not fully meet the user's needs or expectations. But as I know the domain knowledge, I can say this is a good score. So that's all about it. There are a number of ways how you can take this project to the next level by having more and more large language models, making the evaluation process even more lengthier. We will be coming up with another project which is kind of similar text to SQL project but with multiple large language models, but that will be a huge project. Will be up on this course very shortly, where you can actually do a lot of things. A lot of LLMs evaluations will be there, but for now this project is good enough for a portfolio project. Enjoy, and any questions please raise it. The codes will be given in the course resources. Thank you. Welcome to the last part of this project. So what we have done so far is a very comprehensive project. We had multiple Excel sheets, we did some pre-processing, loaded it into MySQL database, right? And then using the MySQL database we created a SQL chain, and then we trained it to the model. Then we also created like a Python notebook where the user can ask a question, and that question basically goes into the large language models chain, and the context is being retrieved here. I can call it as a LLM chain, and from here the output is going to the user, right? So in short, what happens is your Excel sheet goes into MySQL database, your MySQL database schema using which your SQL chain is created, right? As an end user, you are asking a simple question: what is the budget of this particular year? From your simple query, large language model is able to create an output which is basically a SQL query, right? And that SQL query is being passed to the user, right? After that, we actually have another layer which is not by large language model, where we are calling which one? This one, right? If we go above, this is where I'm calling the DB to run this query, right? So this is what is happening outside the LLM box, where we are connected to the database, and this actually goes to the user as an output, final output, right? Not this one. Now there are multiple things that can be done in this particular project, so let's try to discuss few of them, right? The very first thing is choice of LLMs. In this particular project, we have used Google Gemini. Now, why Google Gemini? There is no answer. I just wanted to use Google Gemini, so I used it. So what you can do is you can do multiple R&D, right? Work with multiple large language models. To get started with, work with OpenAI. Take a Olama model like Tiny Llama or something, and Gemini you already have, take this, right? Then what you can do is manually check the results of each of them. That is the first future work that you can do. The second thing that you can do is evaluation metrics. So why don't you run these three through a RAGAS framework, or even with some traditionals, Blue, Rogue, Meteor scores, and then try to create an Excel sheet. The Excel sheet should look like this: large language model 1, large language model 2, and what are the different scores: Blue score, Rogue score, and based on Blue score, let's say LLM1 is good. Based on this, LLM2 is good. Based on RAGAS framework, let's say LLM2 is good. Then you take it ahead. LLM2 should be the best one. That's how we do, right? So evaluation process itself is a lengthy process, so try to do that. That could be one of your potential future work as well. Another thing that you can do is, once you complete everything, convert your code to a beautiful UI, either by Flask or Streamlit. You can directly take help of ChatGPT. If you pass your entire Python notebook, let's say your final notebook is this one, and you want to create a Flask application out of it or a Streamlit application, just give the code. Your 90% of your work should be done. You just have to work on bug fixes, and your Flask or Streamlit application should be ready. And the next big thing that you can do is onboard your Flask to a cloud premises, either AWS, Azure, GCP, Heroku, whatever you can do. You can onboard it, and your work will be publicly available. Now, keeping that link available for everybody or not, it's your call. If you keep it, your budget will increase, expenditure will increase, but that will give you a good hands-on exercise feeling that you are working on a real project, right? That is what it is. I have done multiple Flask applications on my course already. So for this particular project, I have not done. So this is kind of an assignment to you. You can take this as an assignment and try to do all of this future work. There are many other things that can be done as well, but I think these four are the most important things. That's all about it. It is a unique project. It's a real project that we have done in the past for one of my other clients. I hope you will like it. In case you don't like it, or in case you have any questions, please raise a question immediately on the course. See you.